Hello, my friends. Welcome to Origins. What a privilege it is to have you with us today. You know, Origins is a forum where we take the evidence of science and we use it to validate the truth of creation. And today we have one of the great geologists of the world with us, Dr. Andrew Snelling. How good to have you with us.
Pleasure to be here.
And today we're talking about the worldwide flood and evidence for it. You know, if the flood isn't true, the Bible isn't true. And it's so important that we know that we read the Bible with confidence because it's the Word of God. It's the eyewitness account of God of what happened before we got here.
Yes, Donn, and it's important if we think that the Bible is true, we look at the statements that it makes about the flood, and we ask ourselves, if the flood really occurred, what evidence would we look for? And that's what we're going to look at today. But let me just first of all emphasise some of the things, some ideas that scientists use. There's conflicting ideas. Some scientists today believe in catastrophism. That is, that catastrophic events that were sudden, violent, short, and sometimes worldwide in scope. For example, how did the dinosaurs die out? Well, some geologists think that it was a meteorite. Others think it was a volcanic eruption. But what they say is that it was a catastrophic event. And of course, that fits with the global flood in Noah's day. We're looking at catastrophism.
Sort of the ultimate catastrophe.
That's right.
That's hit the earth. That's
but
right.
Traditionally, the view has been uniformitarianism. It's a philosophy of science which says that only the natural processes that we see operating today, geological processes today are slow and gradual. There's no question about it. Rivers slowly carve out the landscape. Sand and mud is slowly transported down to the sea. And it's summed up in the phrase, the present is the key to the past. What we see in the present is assumed to be able to explain the past. But of course the Bible tells us that in fact it's the opposite way around. It's the past, the catastrophic global flood, explains why we have the rocks and fossils today. And we can contrast these two views that the key difference is that with catastrophism you're not tied into timescales, whereas uniformitarianism requires the present is the key to the past. We see things slow and gradual today. It requires long timelines.
They have to have billions of years for evolution to work. But it's a theory that really doesn't seem to line up with what we find in the rocks, isn't it?
That's right. And so we ask the question, if the flood really occurred, what evidence would we look for? We'd expect to find, for example, that the ocean waters flooded the continents.
Right.
And that as the waters came up, they brought sand and mud that rapidly buried plants and creatures. And today we want to look at the evidence that as the flood waters came over the continents from the oceans, all that sand and mud was deposited via widespread rock layers. So let's go to our first example. Let's see what we can see for widespread rapidly deposited rock layers. The reason why we talk about the Grand Canyon is because these rock layers are well exposed to view in the walls of the Grand Canyon here, and we can study these outcropping, and they're a representation of rock layers that we find in other parts of the world, as we'll see in a moment. So I want to focus on three rock layers in particular. We talked about the red wall limestone on a previous program. Red wall is a red cliff, and it's made lime that's turned to stone. I want to talk now about the Tapete sandstone, which is a layer down near the bottom of the walls of the Grand Canyon. And I want to talk about the Coconino sandstone. See how we've got a different name? They're both sandstones, but the geologists distinguish from one another with different names. Let me show you a view. This is what they look like in real life. You can see the Tapete sandstone down here. It's the last little cliff before you go into the inner gorge. The red wall limestone, remember, it forms a red wall. And we can see the Coconino sandstone up here. See how light coloured it is? It's like a little bathtub ring of the Grand Canyon. The Tapete sandstone, the red wall limestone, the Coconino sandstone, they belong to 5 thick sequences of rock layers that can be traced all across North America. I mean, that's an incredible statement.
Yes.
The same sandstone, the same limestone, and this upper sandstone can be traced right across North America. Let me show you a map of the Tapete sandstone.
Wow, it sure
This
can.
is, we've got the Grand Canyon over here where we can see it, but this sandstone can be traced right across North America, all the way up into Canada, right across to the eastern United States. Now the interesting thing is, recently I was in Israel, and we can see exactly the same sandstone over in Israel, halfway around the world. I mean, isn't that the sort of evidence we'd expect to find? Rock layers that went right across the continents because the ocean waters flooded up onto the continents.
The water carrying them was worldwide, so it's leaving the same evidence everywhere.
We'd expect to find rock layers that have worldwide scope. So when we look at the red wall limestone in Arizona, we can actually see the same limestone with the same fossils and the same features in Pennsylvania. We can see it also in England. I had a friend in the Grand Canyon with me from England, a geologist, and when he looked at the red wall limestone, he said, wow, this is exactly what we find in England. But we can also see the equivalent of the red wall limestone right over there in the Himalayas, where of course you've got marine fossils up on the continents, which are indication of the ocean waters flooding up onto the continents. In our next example, we've got the same chalk beds with the same fossils can be found over in Northern Ireland, that's going to the west. But if we go from England to the east, we go right across Europe, under Germany, right over to Egypt and Turkey. In fact, we see the same chalk beds in Israel, and the same chalk beds with the same features in them, the same fossils, the same rock layers above and below, can also be seen in the Midwest United States, from Nebraska to Texas, and also in southern Western Australia. I mean, that's absolutely incredible, Don.
You've just gone around the world.
Exactly.
Yes.
You know, the ocean waters came up onto the continents and they kept on going. The Bible describes a global ocean. Everything was covered. The mountains were covered. And that means the ocean waters went around the world. We've got a global scale fossil deposit of a rock layer that goes all the way around the world. It's always good to show photographs of these features. And so, for example, here's the chalk beds in England on the southern coast. I mean, some of these chalk beds, these cliffs, are over 1,000 feet thick, the chalk beds. And when we go down, zero in at the micro scale, we can actually see what it looks like under the microscope. See that this is about 50 times magnification, 50 times magnification. See the little shellfish? Tiny little shellfish, trillions of them. I mean, if you ever want evidence for a global catastrophic flood,
there it is.
There it is. Well, let's go back to the Grand Canyon again, and I want to focus now on this Coconino sandstone, right? We've seen examples of widespread catastrophically deposited layers. Now we want to look at some of in detail, the features within this Coconino sandstone bed. Here's this sandstone here, you can see it in the distance here, and it's consistent right through the Grand Canyon, mile after mile after mile. It averages 315 feet thick. And here we can see in this photograph, this is the full extent of this sandstone bed. Now, when we zero in at close quarters, we can actually see some features in this sandstone bed. Now, the sandstone is flat-lying, but notice we've got these slanty-looking things here, these layers. Okay, we call these cross beds because they're at an angle to the horizontal rock layer. Now, what do these mean? This is where it gets really interesting and quite exciting, the details that we can glean from the rocks. What these represent are underwater sand dunes, or you say dunes, okay? Or another way of looking at them as sand waves. Okay. Now, we can actually observe these today. Instead of wind blowing and heaping up the sand, this is water. And in fact, if you were to go snorkeling under the Golden Gate Bridge, the water current comes through that opening so quickly from the ocean that the water heaps up the sand as it comes into San Francisco Bay. And so what happens, the water moves the sand forward and it falls back here, and you get these slanty beds like this. But as it moves forward, it erodes off the top of the one in front and keeps advancing. So what you get as you get sequence after sequence of these waves is layer after layer after layer of these slanting beds. Okay? Now we can observe that, for example, in San Francisco Bay. We can also replicate this in the laboratory. So we can work out the depth of the water needed and the speed of the water currents. Let me just give you the idea of the scope. The Coconino sandstone, here's the Grand Canyon up here in this area here. Let me do that in another colour so it's easier for folks to see. okay, the Grand Canyon there. But this Coconino sandstone covers, you've got it's seen in 1, 2, 3, 4, 5, 6 states. It's 100,000 square miles, 100,000 square miles. Isn't that incredible scale where these sandstone beds have been spread? Now let's put together the information here. The Coconino sandstone has an average thickness of 315 feet. We find that it covers an area of 100,000 square miles, okay? And the volume of sand is at least 10,000 cubic miles. 10,000 cubic miles. That's an enormous amount of sand in anyone's language, okay? Now, how did it get there? Well, we talked about these sand waves, and we illustrated multiple sheets of these sand waves. The sand waves must have been up to 60 feet high. Those are huge waves of sand, and the sand waves were being moved along by water at 3 to 5 miles per hour. Now, you might think that's almost walking pace, and it would take a long time, but you know, at that rate, the 10,000 cubic miles of sand would have all been transported and deposited over 100,000 square miles in just a few days.
Sure.
Now you think about those rock layers in the Grand Canyon. A few days for the Coconino sandstone, a few hours for another rock layer, a few days for another rock layer. The sum total of all those rock layers in the Grand Canyon, therefore, isn't millions of years. The time for them to be laid down is only a few months.
Yes.
And the Bible says that the waters were prevailed on the earth for 5 months before it began to retreat. So there was ample time for all this to take place during the flood. Now I have to have an Australian example. This is Ayers Rock in Central Australia. The Aboriginal name is Uluru, but it was originally named by Europeans after the surveyor that found this rock. Now, many people think it's like a big boulder sitting out on they've got the desert sands around here, the desert sands, but they're actually burying more of this same rock. And if you look at this closely, you can see layering in the rock.
Okay, I see that.
I'll give you another photograph so you can see it a bit more clearly in different light. The sun is higher, and we can see see the layering there.
Right.
Now, these are beds of sand that's turned to stone. They were originally flat lying, okay, and now they're being tilted up vertically like this, and erosion has carved out that shape, and the desert sands have sort of buried some of the rock around it. Let me show you again in this next photograph. We can see these beds again. And then in the next photograph, up close. Again, we can see these.
Right.
Okay, so they're almost vertical, 80 degrees. Now, let's go even closer. This is the sand grains under the microscope. And I want to point out 3 things that give us an indication of how quickly this was deposited. First of all, notice that the grains are different sizes, okay? Large grains, medium-sized grains, small grains. Now, what happens if you take sand and mud and water and put it in a glass jar with a lid on it and shake it all up and let it all settle out? What happens? With time, the grain sizes settle out in different layers. The fact that these are all mixed up indicates that it happens so quickly that there wasn't time for the different grain sizes to settle out. So that's the first indication. The second indication is that, notice, we've got jagged corners on these. See the jagged corners?
Yes, it hasn't been
okay.
rounded off.
Now what happens when grains and pebbles slowly roll down the bed of a stream?
The edges come off and
exactly.
becomes round.
They get rounded.
But there was no time for that here,
exactly.
was there?
You're catching on fast. So that's the second observation. The third observation is this mineral over here. See these stripes?
Yes, sir.
This mineral grain is a mineral that decomposes very rapidly. And so that means when you put all 3 observations together, these sand grains had to have been deposited like this, all mixed up very quickly and very recently. Let me just quickly give you another photograph under the microscope. And let's sum up so that we put all this information together. First of all, we've got coarse sand layers that are now tilted at about 80 degrees. The thickness of these sand beds is 18 to 20,000 feet. That's several miles thickness of sand beds. Okay, that's an incredible thickness, but let's look at how far the sand grains were transported. From what we can tell, the closest mineral grains where they could have been an area where these mineral grains could have been eroded from was 63 miles away. 18 to 20,000 feet of sand carried 63 miles. And the only way that this would have happened is that we know that the jagged sand grains of different sizes, okay, and the fresh mineral grains had to imply rapid transport and rapid deposition. And the way to do this would have been sediment slurries that the geologists call turbidity currents that are known to travel at speeds of up to 70 miles per hour.
Wow.
At that rate, the whole 18 to 20,000 feet of sand would have been deposited in a matter of hours. So you see, Don, the evidence is there in the rocks that these rock layers over large areas, great thicknesses, on grand scales across continents were deposited extremely rapidly, catastrophically, and that's the sort of evidence we'd expect to find for Noah's flood.
The scope and the violence of what was happening on the face of the earth is absolutely incredible to think about, isn't it?
It is, Don.
And it's really, there isn't any other way for this to have happened.
Well, it's hard for people to deny this evidence because it's right there, we can eyeball it and we can put all the information together and we can only come to one conclusion, that there was a catastrophic global flood.
We have to go to a break right now, but when we come back, Dr. Snelling's going to be with us and he's going to bring application to this incredible evidence that he's presented. Don't you go away, we'll be right back.
Creation versus evolution. You weigh the evidence. The fossil record, a rapid burial. The Earth is covered with layers of sedimentary rock, much of it containing microscopic fossils such as plankton, pollen, and spores. The visible fossil record consists mainly of marine creatures, including clams, jellyfish, and coral. They are found primarily on continents and mountains, rarely in deep ocean basins. The fossil record is strong evidence for the sudden appearance of life by creation, followed by rapid burial during a global flood. Today's guest on Origins, geologist Dr. Andrew Snelling, is the Director of Research at Answers in Genesis. He's been very involved in technical research, creationist publications, and is the author of Earth's Catastrophic Past, Volumes 1 and 2. Book orders are being taken at 800-778-3390. Andrew has traveled around the world speaking on the overwhelming scientific evidence consistent with the biblical account of creation and Noah's flood. Dr. Snelling has also been involved with the RATE project, which has produced breakthroughs on the subject of radiometric dating. Dr. Snelling can be reached at Answers in Genesis, P.O. Box 510, Hebron, Kentucky 41048, or visit the website www.answersingenesis.org.
We are back with Dr. Andrew Snelling, and he's talking to us about the tremendous trauma that was taking place during the worldwide flood and the evidence that we have for that. Dr. Snelling, we've got water covering the earth. It's carrying huge amounts of dirt and sand. Talk to us about that.
Well, the next piece of evidence we want to look at, which fits in with what we've just said, is that because the ocean waters came across the continents,
right,
we had these rock layers that we can trace right across continents. That means the sediments had to be carried long distances. And so what we next want to focus on is the evidence in these rock layers that the sediments were eroded from distant sources to be deposited right across continents. So let me show you on the screen our next example. When we look at the Coconino sandstone, and you'll remember we saw that sandstone previously,
all over the earth.
The reason why it's white is because it's made up of pure quartz sand. Now, what is quartz? It's the same as window glass. Okay? Now, what we're going to see in a moment, the evidence that this quartz sand is so pure to give that distinctive white colour that it had to have been eroded from a far distance area to the north or northeast and be transported all that way into the Grand Canyon area. So let's look at a photograph of this sandstone so we can get the picture of what it looks like. And here we can see it. Here's the Coconino sandstone, okay? But what do we see underneath it? We see the Hermit Shale, okay? Shale is mud. Sandstone is sand. There's different grain sizes. Now notice that the shale is red-brown, whereas the sandstone is this white quartz up here. So that means this sand could not have been eroded from the mud underneath.
Right.
Okay? But everywhere we find the Coconino sandstone, we've got the Hermit Shale underneath. Okay? The Hermit Shale underneath.
They always go together.
And what we find is that the Hermit Shale is so widespread with the Coconino sandstone on top of it that the sand grains in the Coconino sandstone had to have come all the way from Canada, all the way down, right down to the southwestern United States. There's another sandstone above the Coconino sandstone up there in Zion National Park. It's called the Navajo sandstone, and it's up there in southern Utah. Now, the quartz grains in that sandstone, it's very white, but it contains another mineral called zircon. It's like a radioactive tracer mineral. It's got uranium in it, and it's radioactive. Those zircon grains have been compared with zircon grains in other parts of the United States, and the scientists have come to the conclusion that the quartz and sand grains were actually eroded from the Appalachians over here in Pennsylvania and New York. In other words, these sand grains were transported right across North America from the Appalachians, from the northeast, right down to the southwest there in the Zion National Park area.
That's a long ways.
Now, we've got confirmation of this because, interestingly, there are water current direction indicators that are fossilised in the rocks. Remember we talked about those sand waves?
Yes.
Well, the sand waves indicate the direction in which the water current was flowing.
Sure.
We often find fossilised ripple marks. Everyone's familiar with ripple marks. They show the direction in which the water current was flowing. And so those rock layers that we see in the walls of the Grand Canyon, we see consistently that the water current direction indicators right across North and South America indicate that the water currents were flowing from northeast to southwest, supposedly for 300 million years. Well, that's nonsense. But in terms of the global flood, you imagine a global ocean, the water currents going around the Earth from northeast to southwest. In fact, the man who looked at these measurements, he looked at 250,000 measurements in North America, 250,000 in South America. In Australia, he found the same thing. In Asia, in Europe and Africa, the water currents at this time all around the world were flowing from northeast to southwest, a global ocean. Now, this is the sort of evidence we'd expect to find for Noah's flood.
That's amazing. And so you guys that study rocks, this is a good time for you, I guess. Mm-hmm. But how does this apply to all of us in the church and in the world? Does this really matter?
It does, Donn, because it's not just a scientific issue. It has spiritual implications.
It is all about whether the Scripture can be believed. Dr. Snelling, I appreciate so much the detail and the depth of your work, but most of all what I appreciate is that you are a scientist who said, all right, if the Bible's true, then this is the way the earth would look. And when you look at the rock evidence, you're saying, yes, this verifies the truth of God's Word.
Overwhelmingly, Donn.
Overwhelmingly.
Irrefutably.
Irrefutably. And that is such incredibly important evidence for all of us. You know, it's irrefutable evidence that God did send a worldwide flood, and that if we can believe about the flood, we can believe about the Savior and about eternity. You know, I just want you to remember that it's God's view that He created you. The evidence is overwhelming, and that should be your worldview too.
Thank you for watching this edition of Origins. If If you'd like a copy of the PowerPoint information presented today, you can download a PDF file of program number 906 from our website at www.originstv.org. Or for a DVD of this series, send a $12 donation to cover shipping and handling and write to Origins, program number 906, Cornerstone Television, Wall, Pennsylvania 15148.
Origins is made possible by the faithful prayers and the financial support of you, our Cornerstone Television family.